Why do you suppose nursery pots have holes in the bottom? Because even though individual plants may be watered very efficiently by drip irrigation devices, such as these button drippers, some plants will receive too much water, and the excess water needs to drain from the holes in the pots. This wastes water and also fertilizer. Our goal should be to give each plant only the amount of water which it needs. A float valve could control a shallow depth of water in a no-hole pot, and the growing medium in the whole pot would be moistened by capillary action. Here is an example of capillary movement of water. To start with, we need a no-hole pot such as this 5-gallon bucket. Now we will proceed to build a low-pressure float valve where the nozzle consists of a plastic connector fitting which is inserted into 1/4 inch plastic tubing. Sure tape IT 100 polyethylene foam is glued to an empty, buoyant plastic vitamin bottle. The water flow is stopped when the polyethylene foam is forced against the nozzle. A rising water level causes the bottle to move upward in the 2-inch PVC body, and this forces the polyethylene foam against the nozzle and seals off the water flow. This experimental float valve is designed with an upper pipe which routes the plastic tubing upwards. The pipe fits through a hole in the center of a 2-gallon nursery pot. This stabilizes the nozzle in a vertical position. The pot is placed upside down in the 5-gallon bucket. A 1/2 inch PVC pipe is placed through another hole in the pot for the purpose of checking the water level with a dipstick. Potting soil is added. The upside down pot conserves potting soil. A shallow depth of water at the bottom of the pot will moisten the upper soil by capillary action. Canova canna lilies are planted. The 1/4 inch poly tube is connected to the 1/2 inch poly tubing by punching a hole in the larger tubing and inserting the small tubing. No fittings are needed. Water is supplied to the 1/2 inch poly tubing from a float valve controlled tank. The water level may be measured with a wooden dipstick. A heavy rain raised the water level in the bucket, so an overflow hole was made at a 3.5 inch height to drain the excess water. Looks like the system works. The canna lilies are in bloom, and they consume much less water than if they had been placed in a pot with holes on the bottom and then drip irrigated. The polyethylene foam seal on the right was compressed after 4 months of use. It still works, although it requires about 75% more buoyant force to stop the water flow. Thus it appears that this foam seal has a limited effective life. An improved float valve design was featured in a previous YouTube. It is more stable, has an improved fixed nozzle design, and is easier to build. There is a link to it in the discussion. The improved float valve will be tested in a future trial. Here are 2 other containers of flowers that have also been watered with float valve controlled sub-irrigation. In conclusion, a low pressure float valve will control the water level and sub-irrigate plants growing in no-hole pots using only the amount of water needed. Since water will not drain from the pots, the water consumption will be very efficient. For now, I bid you aloha.